Okay, and we are live. So, welcome, guys, to week 3 of the Celo Bootcamp series. So, if you've made it here today, that's really good. Congratulations to you. So, we are almost at the end of the Bootcamp series. So, we'll be having the last session next week, but then the work will still continue. So, welcome, guys. Welcome so very much to week 3. As you can see, I'm not alone today. Jordan will be joining us in a few. So we have two new members joining us in today. We actually work with them in the Celo Africa DAO team. So yeah, I'll be handing over the mantle today so that they can take us through the NFT smart contracts. But I'll still be around to give out in case anyone has any other questions. I'll be helping them out also in case of any concept needs a lot of explanation, right? Yeah. So, but welcome again to week 3. Thank you guys for being here today. So without further ado, I'll let Ebenezer and Ronex to introduce themselves. Yes.
Okay, GM guys. Okay, I go by Ronex. So literally, I'm going to be among your instructors today. I'm going to take you through like the NFT smart contract, like that the smart marketplace. Okay, so here's my colleague Ebenezer. He's going to take you like through like the basic of NFT. Yeah.
Okay. Hello, guys. I'm Ebenezer. So today we'll be taking it easy, going through ERC 721. That's the standard name given to the smart contract that we build to actually, let's say, produce NFT. All right. So before we begin, we need to understand certain keywords like ERC, right? So ERC simply stands for
Yeah.
Ethereum Request for
Just a
Comment.
second. Yeah, just a second, Ebenezer. So before we continue, we'll first need to like give a quick update on what we went through last week, just to remind people, to refresh people's minds. So last week we were going through like the introduction of Solidity as a programming language. So we were creating like a local directory smart contract. So we went through what structs are, what enums are, how to go through like how to begin learning coding through using the Remix IDE. We also went through mappings where you're mapping a key to a value. We also went through functions. We went through what is a state variable, what is a local variable. So in the event that this is the first session which you're joining in, I'll be sharing the Telegram group where we're giving each other updates, and yeah, where we you can find the recordings of the previous sessions. So this session, it will be a foundational introduction to the NFT smart contract. So the agenda of the bootcamp by the end of it is at least you have like a foundational aspect in creating like an NFT marketplace. So we will handle the smart contract bit. Next week, we'll also go through the front end bit. And yeah, afterwards, we'll give guys like around 2 weeks to finish up on the NFT marketplace, the assignments. And after which, we'll be giving some mini prizes to the best marketplaces, right? Yeah, so that's just a quick housewarming. So I'll be sharing the link to the Telegram group just in case you're not in the Telegram channel. You can join in. And also, yeah, in case you have any questions, feel free to put them in the comment section. So on my end, I'll be doing a bit of checking in to see if anyone is asking any questions, and also doing interjections in case a concept is not understood well enough. But yeah, so Ebenezer, you can continue. Yes. So Ebenezer, if you want to share your screen, you can just share it, and then I'll add it to the stage. Yeah.
Oh, okay. All right. So as I was saying, ERC stands for Ethereum Request for Comment. So basically, it's like a standard that was proposed by the community to basically help bring certain, let's say, if you want to bring your artwork on chain, I mean, how does it like? If you want to represent as in physical works on chain, your artwork, music, certificate, yeah, you can use the NFT for that. So the ERC 721 actually helps with that implementation. So I think before we begin, I think it's good if we all understand the basics. Let me share my screen. Let's all head to Okay. I think I'm sharing it now. Is my screen visible? Okay. So let's all head to eips.ethereum.org. You can just type it in eips.ethereum.org, right? And then press enter. You'll be taken to the website. And then you can head on to ERC in the header, and then look for the number 721. Yes. So the specific name for this ERC is non-fungible token standard. So when we say non-fungible, right, non-fungible simply means unique. So let's say as compared to ERC20, right, where we can create tokens, but then all the tokens are similar to each other in the form or the ratio 1:1. So basically, if I have, let's say, one Celo, like which is an ERC20 contract, ERC20 token, right? If I have one Celo, it's always equal to one Celo. But let's say if I have one NFT, right, and I have another NFT, I cannot say those two NFTs have the same value. So even because of that, you can actually send 0.1 Celo or 0.1 or 0.2 or any fraction of an ERC20 token, right? But then you cannot send 0.1 of an NFT, basically. So you can then go ahead and read the 721. It will open the table of contents for us. Okay. So let's just go through a quick summary of it. Quick summary. So the simple summary. So with a simple summary, it's a standard interface for non-fungible tokens. And as I've explained, we all know what non-fungible means. And then we can use them to represent ownership of digital or physical assets, right? So some of the physical assets are physical property, houses, unique artwork, right? Or virtual collectibles, that's the pictures, collectible cards, and so many on. You can even use them to represent loans, certificates, and so many others, right? So as we all know, with the ERC 721, there is a set of rules, right? Or let's say a set of rules that a set of code that let's say to build an ERC 721 contract, your smart contract needs to follow. So if you scroll down to the specification, you realize the code is actually listed out, and it interfaces the ERC 721 token standard. And I think last week Cindy talked about interface, right? Yes, I think she did. Okay. So let's just look at some of the simple functions. We'll not go through this, right? So let's just look at some of the simple functions. Because today, I think one of our main aims is to actually write an ERC 721 standard smart contract and then probably deploy it. Okay. So let's just go through some of the functions. So the first function, the balance of function. So with this function, right, and as we all know, the basic format of a function is Solidity, right? It starts with a function. So this basically declares that let's see, the line of code is a function, right? And then the balance of which is the function name, right? And then the parameters. So with this, the balance of function takes the address, right? And the owner. And also the visibility is what? External. And then it also retains what? A UN 256 value. Okay. So with this balance of function, right? This balance of retains basically how many NFTs a specific address holds, right? So let's say if you are building your DApp, your decentralized application, and then you want to know basically how many NFT specific address rules, you can include this function, right? And then probably, yes, let's say you can include this function. For now, you can include this function. And to basically give you that, give you that function to in your, in your DApp. So the second function is owner of. So with this, you can actually find the owner of a specific NFT using the token ID, right? So with this, it returns an address. So let's say if I know an NFT, a specific NFT has a token ID of maybe 2, right? Yes, I can enter it as a parameter, and then what's it called? The specific identifier, let's say, yes, of that specific NFT, then to return the address that holds it, right? That's if the NFT is actually what's it called, deployed, right? Is deployed, and I have the smart contract, the contract address actually, yes. So the third function that we look at, right, is the save transfer from. Okay, so with the save transfer from, right, we are actually transferring rights to a specific NFT. So let's say if I create an NFT, right, and then I basically, let's say I can even send it to another wallet using the save transfer from. But with that, it actually checks that specific address I'm trying to send to see if it's not a contract address. And if it's a contract address, there are some, let's say, some procedures that need to be done first. But let me just leave it at the base. So with the save transfer from, the parameters to this are the from, like the from parameter, the address that you be transferring the NFT from, right? The address that you be transferring the NFT to, the token ID, right? And then the byte, let's say the data. But with this, I think the bytes in the data, yes, okay, yes, and the bytes in the data, okay. And I think we all know the what the external means. So basically, other smart contracts can, other smart contracts can, what's it called, interact with this specific function. And then the payable, yes, the payable simply denotes value can be sent using this function. Let's say each or any other token, right, can be sent through this function, this specific function. Okay. So let's take a look at the next function. The next function is save transfer from. I think it's the same. Okay, yes. So with this, you don't actually indicate the byte in the data. So that's where the confusion was something like that. But so it's like the same save transfer from, but with this, the bytes and the data is not specifically a parameter, right? And it's also external variable. Okay. Then we also have the normal transfer from. So with the normal transfer from, you need the address where you be transferring the NFT from, and then the address where you be transferring the NFT to, and then the token ID of the specific NFT. So how this transfer from differs from the save transfer from is, as I said, with this, checks are actually done before you send, right? Yes, but with this, no checks are done. The NFT is just sent, and this actually costs, I mean, more gas. I think Cindy explained what gas is to. So I think it's no gas right now. Okay. And then we have function approve. So with the approve function, right, you can actually approve someone who has an NFT that you minted to be able to actually, let's say, send it to someone else. So to approve an address, basically you need the address that you want to approve, and then the token ID of the specific NFT, right? Okay. So the next function, yes, this works similar to the approve function, but then with this, you can set approval for let's say all address, to like all the addresses you have basically, and then check if they have been approved or not. So with this, the parameter is this parameter is it's a bool parameter. So basically, it's either yes or no, right? Okay. And then with the get approved too, it works similar to the approve and the set approval for all. So basically, this one also takes the token ID of the NFT and then returns the address, right? Okay. And then let's look at the last function right here. So with the last function we have is approved for all. So with this function too, right? It takes in the address of the owner. That's like when I say the owner, it can be the one who minted what's it called, the NFT, or let's say if I have delegated, if I have approved someone, right, to be able to actually send the token, or like I have delegated the right to that specific NFT. So that person can be the owner, and then let's say the address of the operator. So with this, it also checks and returns a bool. So let's say if a specific address is approved, right, it will probably return, let's say, a bool, yes or no. So if a specific address is approved, it will return yes, but if it's not approved, then I think it will return no. I know this is quite, those who are quite new to Solidity, this is quite a whole, I don't know, it's quite cumbersome, but I think if you take it slowly, take your time, look at the function.
Ebenezer.
Yes.
Hi. No, you can continue sharing. I'm just adding to what you continue to share. You can continue to share the EP. Yeah. So I just wanted to add more onto what you've been saying. I don't know if you have mentioned about the different types of EIPs. Yeah.
Okay.
The different types of EIPs. So ERC 721 is one of the Ethereum improvement proposal, which is Ethereum request for comment 721. Yeah, and I believe you've covered the architecture of the different functions and events. Yeah. So in case there is someone who has a question on the chat, make sure to post it and make sure to comment. Yeah. You can continue.
Yeah, and if I could quickly interject also before we continue. So the reason why we're going through, as you'll notice with an NFT smart contract, there's so many methods. So I think it would be best also to give like a general summary of all these methods on a higher level overview of how smart contracts work, right? Or for the NFT. So when you check the NFT marketplace, example, let's say I've made like an image, I've made an avatar or something, and I want to make it into an NFT, right? So you'll find there are several important aspects which are now translated into code in the NFT smart contract, right? Example, ownership, something we call ownership tracking, right? So you will need to know, so at a certain point in time, if I've created this NFT and I'm selling it, we need to track all the people who are gaining ownership of this NFT, right? So you'll find some of the methods which are being implemented is ownership tracking. And that's where when you go and check the smart contract, the ERC, you'll find there's a bit of mapping. And mapping, we talked about it last week, where you'll be mapping like an address and an owner, right? So that we can be able to track who owns each NFT, okay? So, and also to check. So there's a function which I've seen in the in our ERC 721. It's called like a function owner of. Yes, function owner of, right? So this function, it's just to show who is the current owner of the of the NFT. Sorry. So at a certain point in time, if you want to check who's the most recent owner of an NFT, you go through the owner of function, right? So also to check like balances, example, how many tokens specific address owns. So there'll always the function balance of, right? And also there's something else which we need, which is very important in an NFT smart contract, which we call the metadata, right? So the metadata, it's just more information about the NFT, right? So if you click on an NFT and then you find there's a details like, this is an NFT of, let's say, an image or a camera of I took like an image and whatever, just giving out more information about the certain NFT, right? So you need to take the metadata, right? So you'll find it in, if we go down, it's in the function name and function symbol, right? So that is just to show, if you can see it, or it's not, yes, function, just stop, I've seen it, right? So the interface, just to give guys a quick thinking of what an interface is, it's just a blueprint. So the way smart contracts work is, when you see there's an interface in a smart contract, it's like giving a blueprint of all the methods which need to be implemented for you. If you're building, let's say, an ERC 721, and you see there's some methods which or rather some functions which have been mentioned in under an interface, it's just showing all the methods which you have to implement so that you follow the standard procedure of implementing the smart contract which you're implementing, right? Because each smart contract has its own Ethereum request for comments, right? ERC. So if it's ERC 721, you have to have the function name, you have to have the function symbol, you have to have the function token URI. So the interface, it's just like a guideline of all the methods which you need to implement, follow the procedure of the smart contract, right? Now just continue sharing the screen. I'm following you. Yeah. Just
am I sharing?
Yeah. We were following through when you were scrolling. I was using your
I think
sharing my.
okay. I think my screen went dark. So all right.
Okay.
Yes.
Okay. Just continue, right? So we were talking about the interface and some of the methods which you've seen there, like name, symbol. So if you see the interface, it's just giving you like a blueprint of all the methods which you'll need so that you can implement it in the smart contract, right? So far we've talked about, if you're designing an NFT smart contract, what are some of the things you need to put? Like you need to track who is the owner of the current NFT, who is you track the entire ownership changing. If someone sold the NFT, another person bought, you need to also track how many people are exchanging this NFT, right? And also the metadata about the NFT, which we're talking about when I was talking about interfaces, the name and the symbol. So when you're seeing here interface ERC 721 metadata, so the name and symbol, it's just giving out more information about your NFT, right? Yeah, that's why you're seeing it here. And this is under the metadata, right? So this is just more information about the image, okay? And then also, in an NFT, you can sort of give someone an approval to or rather permission so that someone else can transfer your token, right? So that's the function approve. Can you try scrolling it and see if you can see it? Function approve. Yes, function approve. So function approve, the way what is it does essentially, it's you're giving someone else permission to transfer the token. Okay, so if I have an NFT and then I approve, let's say Ronex to transfer my token ID, this function approve will be triggered. Okay, yeah, so when you see function approve, it's just it's just permissions, right? So you're giving someone else permission to transfer your token ID, or rather your NFT ID. Okay, that's why it's there. And then so there are several types of approvals, right? So set approval for all. The function you're seeing here, set approval for all, it means you're approving someone to manage all of your tokens. Okay, so you have several types of approvals, right? So you can approve, let's say I can approve Ronex to manage, let's say, one of my tokens, right? But if I want Ronex to manage all of my tokens, we are going to trigger this function, set approval for all. Right? So that's why it's there. So the difference between approve and set approval for all is just set approve, you're just approving, let's say, one token ID, but set approval for all, you're approving very many people, or rather you're approving an operator to give permission to handle and maintain all of your tokens, right? So that's why it's there. And then also that is now approvals, right? We've gone through approvals. So something else is now the transfer, when you're transferring like the token from someone to someone else. So we have the function transfer. Can you look for it? Yeah, for example, I can see the function transfer from, right? So the difference between safe transfer from and transfer from is the safe transfer form. It's like some sort of, you're ensuring the person who you're transferring the smart contract to can be able to like access NFTs. So the difference between transfer from and safe transfer from, essentially, it's you with safe transfer, you're ensuring that the receiver who will be receiving your NFTs can be able to handle NFTs. Especially, mostly it's used if the receiver is another smart contract, right? So you trigger the function safe transfer from just to ensure that that smart contract is like suitable to handle NFTs, right? So that's the difference between the two. So that's when you're now transferring tokens, right? And then also, one more important thing when you're dealing with NFTs, you need to mint. By minting, we mean you need to produce new tokens, right? And with that, we have the mint and the safe mint. Could you try and scroll where the mint and the safe mint functions are? Can you see anywhere the mint?
I think.
Okay, it's okay. It might not be there, but that's a function also.
Yeah.
Okay, yeah, so that's
Yeah.
another function. So if you're designing a smart contract, you need to make a functionality where people can be able to essentially produce new tokens. So that's what we call minting, right? So it's actually two functions. We have like a mint function and if I'm correct, like a safe mint function, right? And also, if you're minting a function, you also need another function to ban, to remove. So if you're producing, you also need a function to remove. So that's what we call banning tokens, right? So it will be like the function ban, right? Yeah, so I was just trying to give you guys a higher level view of if you're designing an NFT smart contract from scratch, those are some of the design implementations you think of. Okay, who will produce, if I'm producing an NFT token, that will be minting, right? And if I'm producing it, I need to be able to sell it, meaning I'll need to be able to transfer it across people, right? And also, people can be able to manage these tokens if I can give someone permission to essentially manage my NFTs. And also, if I want to destroy it, essentially I can mint it. And yeah, so that's why when you go check like an NFT smart contract, it has several methods, but on a higher level overview, those are some of the design implementations behind these functions. Yeah, I thought to give like a quick overview. Yes.
Yeah, can I? If I would like to like add one more thing about the function transfer. So you would be building, like we will be building our own marketplace, our own marketplace, our own NFT marketplace. So we will have like an NFT. I think Ronet and Ebenezer will be able to guide us on that. We will have our own NFT, and then we'll have an NFT marketplace. So the NFT is like you having the painting, and then the NFT marketplace is you now having a gallery, your own gallery. So the function transfer from and the safe transfer from, or some of the I think the transfer from is the one for a third party market. So you would want to allow your users to be able to sell your NFT to a third party marketplace like OpenSea, or in some of the popular marketplaces for NFT. So when you design your NFT marketplace, you should be able to allow people to be able to do that, to be able to trade, to be able to transfer, and such. Yeah. And then lastly, there are like 9 types of auctions. for NFT, depending with the design you would want. So you would want to maybe people to buy your NFT and such. Yeah, I think Ronet and Ebenezer will be able to speak more on those different approaches. Yeah, awesome.
Yes,
Okay.
yeah. And just to give a quick, just one more thing before I leave the mantle to you. The reason why we're going through the NFT smart contract today is because by the end of the bootcamp, we'll be building like an NFT marketplace. So that we're giving you like a foundation of how the ERC 721 smart contract looks like. And also for the assignment, you'll like finish out on the methods and implementation of the NFT smart contract. And yes, in case you have any questions, please don't be silent. So just speak. In case we are talking Greek, please just tell us in the comments group, and then we'll explain foundly, or we'll explain more instead of floating throughout, right? Otherwise, yeah, I'll leave the mantle to Ebenezer to continue.
Okay. Okay. Thank you. Thank you. So as Cindy and Jordan added, with these functions, right? If you have these functions, and then your main function actually, together with your metadata of your specific NFT, then I think you should be good to go, right? So you'll be able to link your specific NFT with all the functions that you require. Of course, like when you're building the marketplace, you need more functions than this. Probably you need functions to check if an NFT has been sold or not. You can actually add them up. So as time goes on, right, you'll be able to add your own functions and then customize it according to what you actually want. So I think for now that we all understand, let's say, the concept, what makes up an NFT, I think it's time to start trying our hands basically on a simple NFT smart contract, simple ERC 721 smart contract. So let's all head to open the plane, wizard, right? Smart contract wizard. Open the plane, smart contract wizard.
Just a second. Ebenezer, your voice is too low. So can you maybe try talking without
Okay.
people can't hear you well? Yeah,
Okay,
and
all right,
also
all right.
Valeria, can you see the screen right now? So yeah, we are not seeing
Yes,
the
yes.
screen. Yeah, so
Let me.
your voice is too low.
Okay, is it loud now?
Yes, it's better now.
Nice,
Yeah. Sony, can
nice.
you hear me well?
Yes, I can. I can. Okay.
Yeah.
So
So
I
okay.
think
So
we
you
can
can
go
just
to
start by
the
saying what
contract wizard.
you're going.
Okay.
Okay.
So with this, right, opening the plane is like a library where all the token standards are available. So let's say if you want to write your own contract, right, you don't need to actually start from scratch and rewrite all the functions that are available here, right? You can just are available in the ERC 721. Hello, am I clear?
Yeah,
Hello.
so let me just ask you a quick question. Yeah, you're very clear. So someone might have might be curious, what's the difference between the Open Zeppelin wizard with a remix, essentially? Like do they work in a similar way, or
Oh,
is there
okay.
any difference? Why should we use this instead of remix? Yeah.
Okay. So with this, basically with this library, right? This library has been, let's say, the code in this library has been backtested, has been security tested and other stuff. Yes, to actually make sure it's safe. So let's say you rewriting the whole ERC 721 contract, right? One might be a waste of time. Two might be full of bugs and some security issues that, if you are not really sure of, right, can actually cause your smart contract harm. And then also, even in remix, you can actually import the, let's say, contracts from Open Zeppelin and also use them in your smart contract. Yes. So
Okay.
once you have the Open Zeppelin open, yes, let's also open Remix, the IDE, right? And then head on there. So with this, we are creating a very simple NFT smart contract, right? So we'll go ahead and select ERC 721, right? Go ahead and select it. So the name of your NFT. So I'll name my NFT Ebenezer, right? And then my symbol, the symbol of my NFT will be EBN in capitals. So the features I want, right? Let's say if you see a feature and you don't really understand, you can hover around the question mark icon to give you a summary of it, summary of the specific feature they are trying to implement, right? So let's say even with the Mintable, it's telling you if you include this feature, right? Some privileged accounts will be able to mint new tokens, and the bannable, as Cindy said, to destroy the tokens, the NFT tokens, right? And then with the URI storage, you'll be able to indicate where your metadata, like your JSON file, which contains the metadata, to point to. Maybe you want it to point to a file, a specific file you uploaded to IPFS, right? That's your NFT image and other stuff. You want it to point to that specific location. You can also include this too. And then the rules ownable, right? So it's where you authorize, like let's say,
Ebenezer, we are losing you.
other addresses to
And
be able to
unless
own your NFT
it's on my side.
as explained earlier. So you can take your time. Hello,
Yeah, we
Yeah.
can hear
Is
you.
there
We can hear
is
you.
there a way? Okay.
hello.
Yeah. Is there a way you can like move closer to the mic a bit? You're not 100% audible. Yeah.
Okay, am I audible now? Let me stand up.
Yes. Yes. Thank you.
Okay, that's good. So with this simple NFT contract, right? We will not be needing the URI storage for now. We just want to make it as simple as possible, right? So the ownable too, okay, we can remove it for now. Oh, access control. So okay, let's just keep it. Let's just keep it. And then mintable, we can remove the mintable. So we just want an NFT where we'll be able to have our name and then the symbol as a specific symbol, right? So if this smart contract is what we need, then we can just go ahead and then copy it, right? And then take note of the name of our NFT smart contract. Mine is Ebenezer. So I'll head on to Remix, and under contracts, right? I'll create a new, I think I have to move this first. Okay. So under contract, I'll create a new file and name it Ebenezer.so. The extension .so indicates they are writing a code in Solidity, so it will notify the compiler and basically mutate our code, right? Good. So with yours should be different from mine. The contract name should be different from mine. The name of your NFT and then the specific symbol. So in simple terms, this is how a basic NFT looks like. So we can just go ahead, right, and compile it. If you see the green check mark, it means all is good, no errors. Then you can go ahead and deploy it locally in Remix Cancun, right? So we can then go ahead and deploy. That's good. So when we see the green check mark, right, in the console, it means it has been successfully deployed. And over here, we are deploying locally, so it has been successfully deployed locally. So let me. So let me expand the transaction. So with this specific NFT deployment, we see the transaction hash, the block hash, and mind you, this is local. It's not deployed on any external blockchain. So we have a block hash, a block number, our contract address, and then basically where the contract was deployed from and where it was deployed to, the gas fee,
Just a second. Yeah, just a second. Is there a way you can like zoom in so guys who are streaming in can see? You can zoom in on your screen. Yeah, we currently can't see anything. Yeah.
Okay. So sorry about that. So as I was saying, once you successfully deploy your NFT contract, you should see your transaction hash, right? Once you deploy successfully, you see a green check mark in your console. So once you click on it, there'll be a drop down which has this specific information. It consists of your transaction hash, right? The block hash, the block number, contract address, the contract where the NFT was deployed from, the address where it was deployed from, and two, the address was deployed to. By in this case is the constructor of my contract. I'll try and explain that too, and then other information regarding the gas execution code and also the output. Right? Okay. So let me zoom out now. Okay. So once our contract is deployed, we can then go ahead. I think if you look at the left side under transactions recorded and under deployed contracts, right? You see the specific contract I just deployed. You can go ahead and then interact with a contract that we deployed locally. So if you take a critical look at it, right, you see there are some specific functions too. There is a approve function, right? There is a save transfer function, save transfer from function. There is a save, what is it called? Set approval for all functions. The transfer from function. I mean, the functions go on and on. So the reason for this color coding in Remix, so basically when a function button, right, is orange, it means you actually change, let's say, the state of the blockchain. So let's say if I want to approve wallet address, right, I can enter the specific address. So let's go up and let me get some more addresses from other accounts in Remix. So let's say I want to approve this specific address. I can go ahead and then copy this address, right? And then come here, is the specific address, and then the token ID. But with this, I think when we were deploying, right, we didn't actually, let's say, set the mention function to actually set the specific token ID. So getting a token ID here will be quite, will be impossible, yes. So we just need to leave it blank, and as you can see, we get a error encoding message. That's the value of the token ID. But I just wanted to give you like a simple overview of how an NFT contract is, a simple NFT smart contract. So you can also go back to Open Zeppelin, right? And then add various features that we want. So let's say if you want to add the URI storage, right? You can add that. So okay, let me add it, and then we need our base URI, right? So that's where our metadata file basically is. So mostly, like when it comes to hosting NFT metadata files, it's mostly done on IPFS, right? Because with IPFS, it's a peer-to-peer, let me say, storage service. So let's say if I upload a specific file, right, it goes through the file, right, and then provides a specific CID. So once the file changes, right, that specific CID will also change because the file has also changed. So this is because that specific file is read and processed with a specific hash. So once the contents of the file actually change, that specific hash will change, and therefore the CID, the unique like document identifier will also change. So I think we have time to get, so let's head on to Pinata. Let's say Pinata IPFS. Yeah. You can head on there. Yes. So Pinata.cloud, right? So you can head on there. If you don't have an account, you can create an account. I just want to give you like a simple overview of how you will be able to upload your metadata file, and even if it's your art, how you can upload it on upload it to IPFS, and then use it as the base URI here. Okay. So let me log in.
As Ebenezer loads the Pinata, so Pinata is IPFS. That is interplanetary file system. So what it does, it stores, it can be able to store any type of file data. May it be audio, video, PDF, images, and such. So it's normally used for NFTs, but you can also be able to use it for different purposes. So there are different platforms. We have Pinata itself. We also have IPFS itself, which was built by, I think, Filecoin. Yeah. Yeah. So basically, if let's say, for example, beyond the NFT aspect, you're building something that's gonna be validating, maybe like, let's say, like something like a YouTube video, whether it's an original video, whether it's an original video or the video has not been uploaded in another place, then you can definitely be able to use Pinata. If somebody edits the video, then you can also be able to like verify whether the content is still the same size or it's the original content. Yeah. So that is it. Yeah. Continue, Ebenezer.
Yeah. Okay. Okay. So with this, right? Let's say if you have your NFT art, so let me look for a quick picture. So I want a picture of Lamine Yamal, right? Yeah. So
Yeah, so as Ebenezer is going through it,
okay.
is looking for a picture. In case you haven't understood exactly what we are looking at right now in terms of Pinata and IPFS, so remember when you're dealing with NFTs, you're going to have actual like example images. You also have like a YouTube videos, and storing all this information on chain is very expensive, right? Because if you remember, in our last session, when you like store anything in the blockchain using like the state variables which you were talking about, and you like store something on blockchain, right? You call it the method store. So you will use a lot of gas fees. So imagine, and that's just like a method. Imagine now when you in uploading images, even like a YouTube video, or even the picture that you took with your phone, and you want it to become an NFT. So you're not going to store it directly on the blockchain. What you're going to do, you're going to use now third parties. Example now, IPFS and Pinata and IPFS itself, right? So what happens behind the scenes is, so you're going to store the actual image or the actual YouTube video on IPFS, and then now you're going to have like a unique ID which refers to the image. We call it a URI. I don't remember it's called a universal something, I've forgotten. So you will have like a link to the image where it is in IPFS, and that link is what you're going to reference when you now you're building your smart contract. Yes, uniform resource identifier. Thank you. So you have your images which you're going to store in IPFS, like Ebenezer is going to show us, and then now you're going to generate like a unique link which will be referencing to the image, and this link is now what you're going to be using in the smart contract. That's how people store images. They don't store images directly on the blockchain. They use third parties because they'll use up a lot of space. Yeah.
Yeah, okay. Yeah, that's good. That's true. Okay. So I think I'm uploading, but it's not really showing. Okay. So I have already uploaded a picture already. So I think we can use that one. So as you can see, the picture is its name 01, then JPG, which indicates it's a JPEG file, a normal picture. So this is my specific CID, right? So if I can view the specific file, yeah. So this is the content. So the first file that I uploaded, this is the specific content. So with this, we can actually use this link as a URI, right? Or let's say for faster bandwidth, we can, and if I say bandwidth, I hope you guys understand. Yes. So for let's say better rates of acquiring an image, right? Yeah. We can use this resource locator, this specific link, gateway dot the gateway dot pinata dot cloud, right? So with this, then we indicate // IPFS, then / our CID, right? So we'll be able to get our CID from this specific place. We just over on the icon and click it, and then we successfully copy it, right? And then you can paste it to confirm. So once you hit enter and oh, okay. So then I think there's an error with probably the gateway. Yes, gateway sonata.cloud/. Okay. Then let's just stick with the URL that we
Yeah,
can give.
I have a
Okay.
question. So when you talk about gateways, what do you mean? Like when you say there's an issue with the gateway? Yeah.
Okay. So this is how I think I can simply explain it. So as we know, IPFS is actually free, right? So let's say everybody can upload files. So because you are on the free plan, your bandwidth is actually minimized. So let's say if many people are actually accessing their files on one specific gateway, like let's say like one specific link, right? There will be how other people like something like a congestion, right? There'll be let's say a congestion on that specific gateway. So let's say if you are supposed to fetch this image, because there's a congestion, your image might not load in your NFT, or the picture of your specific NFT might not load just because there's congestion on that specific gateway that you are using. So mostly with IPFS and NATA, the free plan, yes, with the free plan, if you realize this preceding URL, it's like it applies to all other people on what's it called? All other people on the free plan. So let's say if you actually upload your image, right, then you also view it, you realize the resource locator is Magneta. I don't know if you can see my address bar. Magneta, blah 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 blah. Then slash your CID, right? Yes.
Okay, so just to give a quick recap, before also our fellow presenter Ronex comes in also. So just to give a quick recap on what we're talking about, we've talked about the basics of an NFT, what the methods, whatever the design implementations behind the NFT, and for those who are joining in right now, we're talking about IPFS and how it fits in with the NFT smart contract. So IPFS is where you'll be storing all your images actually. So you'll not be storing all your NFTs on chain. You'll just be storing them in using third parties. So yeah, just a quick recap of what we are talking about right now. Yeah, so you can continue.
Okay. Okay. So that's good. That's good. So now we have our picture loaded, our art uploaded. So what we need to do next is we need to create a metadata file, a metadata.json file, and also upload it to IPFS. So with that file, it contains the name of our NFT art, right? And if we have a special identifier, maybe that specific NFT has a tag of number 1, right? It's also added, and then it also contains the description. Yeah. So I think with that, for simplicity, let's just use a third party. There is no sign up, I think. Yeah, I think it's Imentify or yeah, Imentify. So let's all head on to imentify.com, or you just type Imentify in your address bar, right? I think yes. The first link that pops up, this one. Yeah. You can basically generate a metadata file using this. Okay. Okay.
So we'll be sharing all these links in the Telegram channel afterwards so that you can go and check them out. Yeah, so we'll make sure to, so Ebenezer, you give a list of all the resources you've shared so far. You post them in the Telegram group so that guys, when they recap, they can see. Okay, yeah.
Okay. So over here, once you open the app, you just go to metadata editor, right? Yeah. Okay. Then we head on to the generator. So over here, we select the standard. Since we'll be deploying on Ethereum, Celo, so we can take the Ethereum standard. So the name of my NFT is Ebenezer, right? And then my collection size. So with this, you can actually have, let's say, 1 or 2 or many NFTs in your specific collection. So you can actually indicate over here how many of them are in your collection. So over here, I think I'll have only one, so I want to put one. And then the symbol of my NFT, EBN, and then the description. So this basically describes your NFT, what about your inspiration, whatever you want to type. This NFT belongs to Ebenezer. That's the description I can think of right now. Okay, so with the advanced settings, right? If you have your image storage URL, you can, paste it here. And with that, you can use the IPFS one. So we copy, right? And then you paste. So let me cross check. Right. I think so. As we are pasting, then a metadata file is actually forming, like as you can see. So I think with this, it will actually be enough. But if you want to add layers to your metadata file, you can too. Or probably your file is not hosted on IPFS, it's hosted elsewhere, right? You can maybe your file is a YouTube video, it's hosted on YouTube. You can put the URL here. Okay, so I think that would be enough. So with this, then you can go ahead and download our metadata. So we'll be able to obtain our metadata file in a zip, right? So you can just go ahead and extract it on zip, and then on archive. Yeah, it's on archive. So let me put it documents export. Right. Okay. I think you should have it by now. Then we can head on to Pinata, right? And then add our metadata file. So with this, we need to actually rename our metadata file to match the name of our app, our NFT app. It's not really compulsory per se, but for Unison, so let's say if you have your NFT name 01.jpg, your metadata should be 01.jpg. So as to identify each let's say artwork and its corresponding metadata file, right? So let's go ahead and select rename. So 01, yeah, and then can go ahead and upload it. Okay, file has been uploaded successfully. Let me refresh my page and see if it shows. Okay, so now it's showing now. So with this, we also have our CID. Yes, and as you can see, it's different from this, and I think you know why. Okay. So we can actually view our file and then get our URI, right? Copy it. So if we want to, let's say, create an NFT with a picture, right? I want to create my NFT called Ebenezer with a picture of Messi. I can put the base URI here, right? And once I deploy it, let's say if I deploy it on a testnet, and then I go to OpenSea, they have the mainnet OpenSea marketplace. And those who don't know OpenSea, it's like a popular NFT marketplace. So they have the mainnet and then the testnet. So since we might be building on testnet, if you create testnet NFT, you'll be able to view them on the OpenSea marketplace. Once you search, once you input your specific contract address in the testnet search bar, right? They are marketplace testnet search bar. Yeah. Okay. So let's go ahead and then Onabo, yes, select Onabo, and then Mintabo, and then Benabo. Yes. So I copy it, right? And then go back
A
to
question,
Linux.
quick one.
Good. So we have our.
I don't know if you can hear me. Just a quick question
Yes, I
on
can.
the Banabo. Yeah, just a quick question on the Banabo. So we have Mint, maybe in Banabo. Why would we need maybe Banabo in an NFT? And what impact would it have in terms of maybe gas related issues, and what impact would it have in the NFT? Yeah.
let's say the bannable function, right? So like a user or a holder can actually decide to bend their token. So let's say if I was minting a collection, if I was creating a collection and I created 1,000 pieces, let's say 1,000 NFTs, and then after deploying it and everything, probably I've been able to sell five, right? And then I can decide to probably bend the rest and keep the five to increase the rarity of that actually happen, right? And then maybe some users buy some NFT and then probably later they decide they do not want to own it again, right? So probably they can then burn their tokens, they can destroy their tokens. Yes. I don't know if that's what you're asking.
Yeah, so just to give more context, like what we were talking about previously, so the ban method, right? So when Ebenezer has clicked on bannable, it's just to give the owner of the NFT smart contract the ability to destroy their own token. And you might use it several times. Let's say you put like maybe something which was incorrect. You maybe uploaded an incorrect token or an incorrect NFT rather, and you want to destroy it and you want to completely destroy it. So that's why we make the bannable function. So in the event you want to destroy some of the tokens, you can. So if you don't want to destroy the tokens, essentially you just not input the ban method. Yeah, so the ban method is just it gives the owner of the of the NFT the ability to destroy to destroy their NFT. Yeah, so that's what we normally mean by banning. So even when you see a lot of let's say you're checking out even other smart contracts and you see the token was banned, essentially it just means the token was like destroyed. Yeah.
Yeah, the other question was on what is the impact of it on the NFT. Yeah, like in terms of gas, what is the impact of the bannable function in terms of gas? Yeah.
Okay.
Yeah, could it affect the when you do the banning? Could it maybe like affect the price of the NFT? Could it also maybe affect in terms of maybe gas fees and such? Yeah. Because the reason why it would also be able to the function would also
So
be there.
when the price of the
Oh, sorry. We lost. I think. Can you hear me?
yes,
Oh, okay. So I was looking at it in this angle. Like when we have like a high demand of an NFT, like we drop an NFT, and then there is a lot of demand for a specific NFT, like the way we had the body craze. Yeah. So would
yes.
the function be able to like affect the price drop, or would it affect the price in terms of also price and yeah?
Oh, okay. I think with that, no, it won't necessarily affect the price of the whole collection per se, because most okay, so there are actually two ways. So it actually depends also on the auction system of that specific NFT. So let's say if an NFT starts at probably zero, starts at nothing, and then users are supposed to bid, right? Maybe I have five in a collection, and users are supposed to bid maybe the first NFT, and they were able to bid up to one Celo, and then the second one probably 0.5. So let's say once I realize probably I've done a mistake with the first NFT, the one that sold for one Celo. Once I burn it, I don't think it will necessarily affect, let's say, the rest of the collection, as in the price of the collection. Though it will increase the rarity of let's say that specific collection, because now it has been reduced from 5 to 4. I don't think it will, impact the price in any way. If the auction system is um, the normal users bidding, then the highest bidder wins.
Yeah.
Does
I
that
think
answer the question?
yeah, it does. I think one of the thing it also does is to like increase the price because the correction now becomes rare. Yeah, the correction also becomes rare. So if you had like 100 NFTs and then you ban like
Yeah.
10, the correction goes on being rare. So it becomes like those rare cars, that are created. And then it becomes expensive. Yeah, I think your screen dropped. You can put it back. Yeah.
Yes, it's back now. Okay. So I think we have a complete NFT with a URI and everything. So you can go ahead and deploy locally. So let's go ahead deploy. So once we successfully deploy, we will see the transaction in our console. So we can zoom in, check it out, right? See our transaction hash, block number, our contract address. The contract address is really, really important. Yes. So we can go through um, some of the other information that's available here. Okay. So let me zoom out. And then we can then come and interact with the contract we deployed. So this one is the one I deployed earlier. So I can play. So the new one I just deployed, coming. We should have a banner. I don't think it is coming. Let me deploy it once again. Okay. So this is it, right? So you can interact with our NFT smart contract, right? So let's say if you want to find out the symbol of our NFT, we can call the symbol function. So once we call it, you realize there is feedback. So let me zoom in. As you can see the feedback is string, and then it's giving us the value EBN. So this is actually the symbol of our NFT. If I call name to, okay, if I call name to, you realize it's also returning Ebenezer as a string, right? Okay. So if I want to find the balance of a specific address, like how many NFTs, let's say that specific address has in my collection, I can input the address here and then call it. So I think once you deploy your own NFT contract, you can go ahead and then interact with it. Right? You can try and send some NFTs to your friends and other stuff. Yeah. I think for now, this will be all. Since we've been able to write our own NFT smart contract, basically know what functions are actually present in, in the ERC 721 smart contract, and then we've been able to deploy it to locally on Remix VM Cancun. I think that'll be all for the basics of ERC 721. So let me just give a simple recap, a very quick one. So with the whole ERC 721,
I think it dropped Ebenezer.
Yeah.
we started with website eip.ethereum.org, right? So we went to the so basically contract with just our name and the symbol. We minted it, created our own NFT, the remix campaign, the local.
Okay, I think we lost him. Yeah, so when he gets live, we
Yeah.
can
As we
yeah.
wait for Ebenezer to come back, there is a question here. Patrick is asking: does the current owner get revoked access to the smart contract or NFT after safe transfer or transfer from? That is a really great question. Who wants to pick it?
Okay,
Let's
really,
give Ronex a chance. Yeah, because he hasn't spoken. Yeah.
Yeah,
okay,
yeah.
no. Okay. Once the access revoked for the smart contract, maybe, for example, maybe the marketplace can revoke a user. So like that NFT does not belong to that user, the current user. Like like he does not own that NFT currently, so he cannot do anything. But like he or she, it does not being she's not being revoked to access the smart contract. He can access, but they cannot transfer the NFT or maybe use it.
Yeah, exactly. So the transaction will still be there. The previous ownership will be there. So it will be just be like a hierarchy. So it will be able to show like Ronet transferred the NFT to me, and then it went to Cindy, and then all the way to Ebenezer. So the transaction history will be there of the transfer. But I can still be able to maybe repurchase the same NFT, and then the ownership will be back to yeah, like that. Yeah, awesome. So I think the next part will be Ronet, who will be showing us how to cook.
Okay, okay. Let me just let me just do a deep dive. Okay, I'm going to all that said and done. I'm going to do like a quick marketplace or like an auction marketplace. Let me just share my screen in a few.
Yeah. Welcome back, Ebenezer.
Yes,
We are
thank
about
you.
to cook.
I
We are
like
about
to
to
cook.
We're
we are
about to go.
about to cook.
I realized I was receiving a call, so I don't know. My network was uh,
Yeah, it's okay. It's okay. But you are about to cook now.
Tell you. Open my screen is up.
Yes.
Okay, for the newcomers, okay, tell you this remix, like just like a quick ID environment, like to just develop quick smart contracts. So I'm going to do like a quick deep dive into our marketplace. Okay, let me just spin out here like a file. I'm just gonna call it Celo, maybe Africa that's all. Okay, so literally, okay, so like the normal rules literally, I need like to get like the license and the version of the solidity. So for me, I'm going to use like this is 0 point maybe 0.2 exactly. Okay, so currently, let me just give you a quick deep dive on what we are going to do here. Okay, so you're about to like to come up with a marketplace, like an NFT marketplace, like an auctioneer, where maybe like a user can just list the NFT, they can mint the NFT, they can list the NFT, and release it back to the marketplace. The marketplace can handle like the buy and selling. Literally, like the user can see like their NFT, like that the previous NFT that they already like registered in the marketplace, and maybe they can set price as well. Literally, yeah, nothing's for free. Yeah, we're going to charge some fees. Exactly. So the first thing we need, literally, like Benas talked about like some metadata. So literally, we need to get some storage metadata. So that's from the
Ronex, could you like zoom in? Yeah,
okay.
so guys can see. Yes.
Is that good?
Yes. Yeah, thank you. Yes.
Okay, good. Okay. So, okay, the first thing we need to get like the meta, like the URI, that the uniform resource identifier. The next thing we need to get like an interface for the ERC, that the Ethereum LC71, that the Ethereum request for comments. Then the other thing, I need to like to get like a unique ID, because we have said like for you to mint an NFT, it's required like for you to like to have a unique ID, which you're going to combine it with your metadata URI. So I need an ID. Okay, so let me just import this stuff. So literally I'm going to import like the interface for the metadata. I'm going to take it from OpenZeppelin. Literally OpenZeppelin, like this, they are standard like place for you to get like the like I can say audited smart contracts. So I need to get an ERC 721. Yeah, your right storage, as you can see. Okay, so literally I need to import like the ERC 721, that the interface which contain like all the features of an NFT, like from the mintable, safe transfer and all. I'm going to get it exactly from OpenZeppelin. I'm going to get 721. Actually, I need an ID. Like I need to get maybe like a library like to give me like unique IDs for me like to just mint unique NFTs, because we have just talked about like NFT like is a non-fungible token which is a unique. It cannot be split into simpler portions. So I'm going to spin off here some library. I'm going to use some counter from just open exactly. I'm going to use counters. Nice. Okay, so the other thing, we need like the name of an NFT. So I'm going to just drop a quick name. Maybe you're gonna call it Celo Africa DAO. If you have any question, just text there on the chat.
Yeah, in fact, you actually have a question from Patrick Kish. I'm just going to quickly read it. So, question: when a transfer from or safe transfer from is executed, does it revoke access of the previous owner, or does it work like providing access to a new owner? Yeah.
Okay. So really, when the safe transfer is being invoked, okay, you just transfer the ownership. Okay, for example, maybe I'm the shopkeeper here. I'm owning like I'm the one selling like maybe some bread and stuff. Okay, so you come here like a customer. So I'm just transferring you the ownership of this bread. So it's coming from me to you. So literally, me the shopkeeper, I will not own it anymore. So you'll be the current owner. So literally just like transferring for good. Hope that answer it.
Yeah, maybe I can add more to the context, the same context. You see the way you have land ownership. You transfer the title deed from one user to another. So it means that the ownership is still there, that the previous ownership is still there, but they don't have access to the title deed normal, but they still have proof that they used to own that particular title deed. It's the same thing for the NFT, just like the way Ronet has said. Yeah. So before I give you the mic back, Ronet has also talked about the auction. So there are different types of auctions, and OpenZeppelin has utilizes one of the auctions, that is the English auction. So it's when you have so many NFTs where bidding occurs until like a timer runs out. So you have like a timer, and then people bid, and they bid until something the time goes off. And then there is the last one, which is the Dutch auction. The Dutch auction works starts at a higher price and then decreases until someone is willing to buy the NFT. So, but the most popular one is the English auction, which OpenSea utilizes. I think that is one of the factors that you also would be considering when you're building your NFT marketplace. Yeah. So let's you can continue spinning.
Okay. So here we have like some good library like call counters. Let me just go quick over it. So as you can see, okay, this is the rebel counters. Like okay. So really, like they have different, like you can define an interface rebel and stuff. So here is my rebel, which I'm going to use maybe to get like those unique IDs. So as you can see, you have a structure. These are user defined data type. Okay, so we have our current. Literally, I can get the current value, like from the value. I can increment that value. I can increment that value. These are just functionality. And check this as the low level of solidity. Okay, so I can set the value. Okay, let me just back to my marketplace. Okay, so first of all, I need like to initialize like that counter. So for example, for you to initialize Rebel to using Solidity, you just like using like you just use this name like using. I want to use the counters library. Use counters for. I just want to get to the counters. Then I want to get to the counter that is the strat. Exactly. So really, I've just like spin off that library. So I need two things. I need to keep check of my current IDs. So I'm going to just spin an UN 256. As you can see, this is just 2 power 255 minus 1 bits. So I'm just going to use UN 256 for memory. So I'm going to just make it private maybe. Yeah. This is the access. Wait. I'm going to call it 56, then I'm going to call it what? I know. Let me just use the type from the counters. I want to use the counters from the counter, that struct. Then I want to give it maybe private. Then maybe I can call it token IDs. Exactly. So another thing, I want to keep check of the item sold. So I'm going to spin counter from the struct counter, same private. Maybe you can just maybe keep it public, no worries. So I'm just going to keep it item sold. Okay, so the other thing I need to come up with a struct for me to define like what my marketplace will hold from an NFT. So I'm going to spin here a struct. Maybe I'm gonna call it market item. Yeah, market items. The item, just one. I want this one to hold UN56. That's the ID. The token ID. That's the ID for the NFT. Okay, you guys, you should maybe be keen for this one because this will be one part of your assignment, I guess. Okay, so so the other thing I want to keep check of the buyer and the seller. So I want to spin off here an address. You can say this is the seller of the NFT. I want to keep an address, the owner of the NFT. Okay. When I say the seller and the owner is the person who means the NFT. The seller maybe gonna be the marketplace. I'm going to maybe to give it some, maybe I can say powers for it to like transfer or sell on my behalf.
It's the car dealer.
Exactly. Okay, so the other thing I'm going to keep check of the price. Maybe for example, I'm minting my NFT. Maybe I want to set a price to like for me. For example, maybe when the auction resell it, I'm going to get some cut. So I'm going to maybe keep value here for the price. The other thing, I'm going to check if that NFT has already been sold by the auctioneer. Exactly. Okay, so because I want to interact with the native currency, not the ERC20 or the stables, I'm going to give these guys some payable in order for them to accept some native currency. Exactly, payable. Okay, the other thing, now I want to map here, like I want to map the NFT ID to a specific market item, like for a user. So I'm going to call a mapping here. So literally, I want to call UN 256. Can call it maybe an ID. So I want to map it with the market item. I'm just gonna name it public. Anyone can access it, because why not? So ID to market item. Exactly. So that's a mapping, like just for you to map an ID to a map, like just like a dictionary key value type. Okay. The other thing, let me just pin here an event, literally for maybe for example, like to give logs. So I'm going to create here an event.
Yeah. So that one is to check how much gas fee we have used. As we spin.
Okay, so let me just what's the better name? Let me just create market item. This is an event. Literally, okay, for the event, I want to keep track of the address of the seller. I want to give it index. For example, maybe if you're using like the likes of graph, you can access it like off chain using this. Maybe let me just call it seller. The other thing, I'm going to give an address. Yeah, I'm just going to index it. It's just like a key type. Maybe I can use it to search it on off chain. Let me just call it owner. The other thing I'm going to put is the price. The price. Okay, the other thing I'm going to keep track of, maybe, is it all? No, the token ID. That's so important. In 56, let me just call it token ID. So we can know like when the token was minted. Exactly. So here's my first function. Oh, okay. Before the function, these guys, they're supposed to pay some fees, literally. Because why should they release some items for free? Yeah, something for free. Okay, so I'm going to initialize like a unit 256 here. Okay, I just want to name it public. Okay, anyone can see like the listing price of, for you to list an NFT in this marketplace. I'm going just to call it listing price. Okay, so for now, maybe you can just say the listing price for an NFT maybe just 0.00. Let me just put 25 ethers. When I say either, this like, okay, these are just denomination for the some tokens on the chain. So like this, like I can say it like 10 multiplied by 10 to power 18. Those are the decimal places. So we have ethers, we have way, of which is like 10 multiplied by 10 to power 9, etc. Okay, so so first to list like to list an NFT, yeah, we are going to charge 0.025 ethers. Okay, so the other thing here is about now like okay. And okay, so for now we have like a basic skeleton. Now I need like to inherit the ERC721 storage. Let me just copy it.
Ronet,
Yep.
you've moved from spinning to inheriting. So could you
Okay.
could you tell us what are we inheriting? Like, and exactly why? Yeah.
Okay. Literally, Ebenezer have spent here like an hour or so, like walking through like the interface of ELC721 and stuff. So for you guys, you saw like for you maybe to come up with an NFT, you need like the EAP 721. For you, you need like metadata, like for you storing the metadata of the NFT. So literally, this marketplace as it is, it does not know about anything about an NFT like that EAP or something. So I want to inherit some function from those interfaces for me in order to to make the marketplace like to use the NFT or to be in charge of the NFTs. Literally. I hope I'm right, Jordan.
Yeah. So maybe as you inherit, we can add more. So
Okay.
I think the guys who have been able to like go through the object-oriented way, there is inheritance, there is encapsulation, there is and all those things. Yeah. So inheritance is and encapsulation is more of like data hiding and such. Inheritance is like the way you would be able to like inherit some of the features from your parent and such. So that is exactly what Ronets is doing. So he wants to inherit the features of an ELC721 so that he can be able to use them on the marketplace. Yeah. So yeah, let's spin it.
Okay. As you can see, literally, I've just like inherited the ERC721, but my contract is complaining. Okay, let's just check it about. So it's saying like we should just like initialize like the contract as an abstract. As you can see, if maybe I can keep this contract as an abstract contract, literally, yeah, my error is like it's completely gone. Okay, for an abstract contract, it just means like we have some function which are already initialized, others are not to be initialized. So okay, so when we inherit like and like a smart contract, you need to initialize like some requirement functions, like for it maybe to not be identified as an abstract. Okay, so for me, actually, I guess the thing which is like missing here, just like a constructor, where maybe I'm going to give the NFT name and the symbol. So I'm going to give you a constructor.
Yeah, and could you explain as you continue like what a constructor is? Yeah.
Okay. Let me just take you back to the, I can say, object-oriented stuff. So like a constructor, like this, the first function, like which is being run when you deploy your smart contract. Okay.
It's the ignition.
That's the key. Okay, so I'm going to just inherit that in this is 721. Okay, so here it just expects two things. It expects like the name of the NFT. Me, I'm just call it Celo Africa DAO. Literally, you can call it any name you want it, and it just 12 some symbol. So I'm gonna call it CAD. Exactly. So I help my contract what complain again. Nice, cool. Okay, the other thing you forget, I guess, here. Okay, so who owns this NFT? Like, who is the sole proprietor here? Okay, so let me just add an address here. Address. Let me just call it public. Anyone can see it. I think you're hiding here. So address. I can call it owner. So this is the guy who is gonna receiving those listing prices and stuff. So that's the owner. So I want okay, when you just deploy a contract, I want just to automatically assign an owner like an address. So I'm going to call it an address. Let me just call it owner. Then owner. Oh, there's something here to tell you. I've just forgotten. Okay, so as you can see, I'm not. For this action, we are just interacting with the native tokens. For you to receive a native token with an address or maybe an external, you have to be a payable, which means this guy can receive it literally, just like a key. So payable owner, not payable owner, public payable owner. I guess that won't work. Okay, so the other thing, I'm going to keep it payable. This guy's complaining. Address payable public owner. Nice. Okay, so the other thing is about so let's now go to the minting of the tokens literally. So here I'm going to create a function here. Oh, okay. So okay. Let me just walk you through what I've just committed here. So okay, this is my plan. I want just to create a token, a function which is going to mint some token to a user. Then the user will going to pay some listing price to auctioneer. Other thing we want to resell it. If I just bought an NFT from this auctioneer contract, maybe I just want to change the price and then resell it. The other thing I want to fetch all the marketplace NFTs, fetch the user's NFT, get the current price listing and the set new price listing. Okay, so let me just come here, create a function. If you have a question, just ask. So create token. Okay, so this is going to be public. Anyone can call it. Can we give it external? Can be external, payable. Anyone can call it. I can even return. So I want to return the UID of the token. 1256. That's the token ID. Exactly. Okay, so the first thing I want to let me just rename this.
Oh yeah, and as you continue, I've just remembered something with regards to inheritance. So you can actually inherit several smart contracts. So you're not just limited to one. So depending on the specifications or rather the functionalities which you want for your smart contract, and since the way NFTs work, they mostly implement the standard implementations given by OpenZeppelin. That's why we're using OpenZeppelin a lot. Yeah, that's why even previously we didn't do anything on inheritance last time, but with NFTs you find yourself inheritance, it's just reusing the code, right? So if you want several functionalities, let's say you want to implement Bannable, so you go for bannable.sol. You want to implement something else, so you look for its implementation in OpenZeppelin, so you can inherit several smart contracts. You're not limited to just one. Yeah. The only now thing is when you're duplicating, when you're implementing or rather when you're inheriting several smart contracts, you have to make sure they don't have the same function so that they don't sort of clash. Yeah, so they don't have the same like function implementation, so that as you continue to implement and you have a specific function which you want to use in your smart contract, they don't clash when both of the smart contracts have the same function. Yeah.
All right. Okay, let me just continue, Charlie. Okay, so this is the creating token functionality. As you can see, I'm using like my regularly, which when I say current, like the moment like haven't like done anything, by default is 0. As you can see, like the default value is 0, by default is 0. Like this is just a library and external library. Okay, so the other thing. So, okay, so I'm just getting that token, that the token ID, the 0. I'm minting a token. I'm minting this NFT, Celo with the symbol like CAD. I'm minting to this guy. Whoever called this contract, I'm going to mint it like that token 0. Then I'm going to set token URL. Okay, here where the storage contract comes in for me to save the metadata. So I want to save like that token ID like to that token URL. Okay, literally, as you can see, did you mean token URL? Okay, literally haven't initialized it. Okay, so literally, as you can see, Ebenezer mentioned like you just go to OpenZeppelin, deploy like an image, get that URL. So that's what you're going to pass here. So it's literally going to be a string. Memory. What is this? Memory. Maybe I'm going to call it token URL.
Yeah, and for those who have forgotten the reason why he's writing memory after string, it's because we said last week when you're writing, or rather when you're using strings in Solidity smart contract, you need to specify the location where they are at, because strings are more of a complex data structure, kind of like how structs and enums look like. So it's a very complex data. It's like an array of bytes essentially. So that's why he has to put memory there. So it's like telling the Solidity compiler that my string will be located in this and this data location behind the scenes. Yeah, just a by the way, as he continues.
Okay, literally, okay, I want to make this functionality like private for you to create like a market item. Not anyone can call it. Like you have to call it through this create token. Okay, so literally I'm missing two things. I'm missing the function and I'm missing the price. Like for you to create a token, maybe you like want to initialize it with a price. Okay, let me just add that one. Exactly. Now I have the price, but I don't have the function. The function is still complaining. I haven't just created it. So the other thing, I need to increment my token IDs, like in order to go to like to the next. So the first one is 0. Like the next one is going to be like 1. Token IDs. So dot increment. Exactly. So I'm going to increment that one. So here I have something which is complaining. So the create market. So I'm going to create that function, which is going to be like private. So function create market item. Nice. It's going to take two things. It's going to take an ID, of which is a uint 256 underscore ID. Then going to take another thing, uint 256. That the data type. Going to take like price. Nice. So this is a private function.
Exactly. Yeah. So with regards to that, could you maybe tell us design wise why you've decided this function will be private while other functions may be public by nature? Yeah. So what design aspect did you put behind this to say that the create market item is going to be private?
Okay, so literally, okay, this is my like what I was doing literally behind the box. Okay, I was like creating here a function, create token, and then I separated the create market item, because the create market item, this is where the transaction is gonna taking place. So I don't want anyone like outside, like anyone can call this function outside this smart contract. Literally, only this smart contract can call this function, because like it's like a critical function. Like because here is where like some transaction are going to happen. So that's why I separated like from the external. Anyone can call this function, and this create market item, only this contract can call this contract, like this function. Yep.
Yeah, and just to give more information, when we say the function is private, essentially you can actually see this function when you go through the smart contract after it's deployed. Okay, we don't mean that it's not going to be seen in the smart contract. It's just that other smart contracts can be able to call this function. Yeah, so that's what we mean when we say like the function is private. So you can still see it when after Ronex deploys the smart contract, and maybe you go and check it out on the blockchain explorer, right? And you go through the smart contract, you can still see the function, but it's just that when other smart contracts, they cannot sort of interact with this function. Yeah.
Okay, so actually, I've just said, okay, that's like just like a critical function. Okay, so actually, I don't want like anyone like just to just put like a price of 0, like why should you like put a price of 0, like then this is an action, yeah. So I'm going to put here like a check, where I'm going to check this price, which the price which is coming is supposed to be greater than 0. Then yeah, maybe if you put a 0 or maybe anything less than 0, but which it can't be anything less than 0, because these are uint56, which start from 0 up to 2 power 56 minus 1. So here I'm going to maybe like just say can't be 0. Totally, this guy can play with us. So can't be 0. Okay, so that's the first check. So the other check, literally, I need like start like the price. Why are you complaining like that? Okay, so the other thing, like, so we need to put a check here, because we are doing like some payable, like as you can see, payable thing. Literally, like we are transferring some native token to this auction contract. I'm going to put a require here, where I'm going to say like the message value. Okay, this is an inbuilt function, of which like this, like the value, like, okay, for you to call this functionality, for you to call this create token, like you have to pass some native token here. Okay, for our case, maybe that is Celo, the token, not like the stables. So the message of value, so like it just starts like Celo, the native token. So here, literally, it has to be okay, this one is like, it has to be like same as the listing price, because you have said for you to deploy in this auction, you can't deploy free, like you have to pay some stuff, you know. So okay, so message value, so it has to be equally to the listing price. So like you have to pay some fee in order for you to mint some token in our auction. So you can say just price can be more. Okay, actually here I've gone out of the standard like writing for errors, like they're supposed to be short for you to save some gas and stuff. Okay, so the other thing, now I need to create these market item. So as you can see, I'm going to map to take the market item. This is a mapping which takes an ID, uint as key. So I'm going to pass that ID as key. Then I'm going to create here a market item. What was the name of it? The name of the struct market item. Let me just copy this. Market item. Okay, so here literally I'm going to do like a deep check, like for me to make sure like haven't maybe like misplaced some values, for example the owner and the seller. So literally I'm going to say the token ID. I'm going to give it the ID. Then I'm going to do another thing. So I'm going to the seller. I'm going to put it, the seller actually, this is the person who is selling. So literally it's going to be message dot send, I mean. The other thing is about like the owner, because literally this is our logic. When you mint an NFT, literally you mint, and automatically you're going to transfer that NFT to the auction in order for it to resell it for you. So I'm going to give the owner, because that will be the owner of the NFT after I've just transferred. So the owner is going to be address, the address of the contract. Let's address this. Okay, the other thing is about the price. Going to be that of the price. Okay, so the other things about is it sold? So by default it's false, because no one has bought it. I'll just hey, what's up? What's wrong here? Oh, they're supposed to be payable for them in order to accept the native currency. I hope we're together though. Hello.
Yeah, we are following through.
Yeah,
Yeah, in case of any
We-
questions,
yeah.
we're checking the comments. We're here, we're following through.
Just the silence. Okay, so payable. So what the other thing, yeah?
Maybe to to break the silence,
Okay.
you can talk more about they're like basically they're like two values that starts with is it types or inbuilt values, that is message.sender, there is message.value, and then there is the other one. The common ones are msg.sender and msg value, but the other one keeps on running away.
Which one? It is an MSG.
Is an MSG value. There is also an MSG sender. The other one keeps on running
Okay.
away. Yeah, message.data.
Yeah,
Yeah,
that's
yeah, gas and yeah. So they all have different functionalities. Like for MSG.sender, it's gonna be picking the exact address of the person interacting with the specific function. Where the value is gonna be picking an actual value from the without having to like type, yeah, the value
Okay.
that you have already defined, yeah, which is like the listing price. It was 0 point some, was it 0 point something, I think.
0.025 ether.
Yeah.
Okay, let me just continue, Charlie. So literally I've just mapped like that market item. So the other thing we need to like to transfer the NFT, because currently who is owning the NFT? Like the person who minted it. So whoever calls this function will be the one who owning the NFT. But I want it to like to just transfer it like from that person to the action contract. So I'm going to call the transfer, literally the transfer function. Exactly. So it has to be message or sender. The girl is calling that function. Okay, too. I want to pass it to this address. So like for you to just like to get the address of the specific contract which you're working on, where to call address this, yeah, that's the contract of whenever I'm going to deploy that contract. Then I'm going to pass the token ID. That's the ID, actually. Exactly. Okay, so the other thing, because these are like it's work under a payable of which way it's taking the message value, we need like just to like to send that listing price to the owner of the contract, I mean the auction. So I'm going to call the payable. So this is the payable function of which going to be, I'm going to call it owner. So the owner is going to receive this one. Then I'm going to call transfer. I'm going to pass it just the listing price, I guess. Yep. Listing.
Yeah, and just in case anyone missed the previous explanation, the reason why he's using the payable method, he's calling the payable method because this function will be able to receive essentially ether and also send ether, right? So the reason why he's adding the payable in front, even in the previous function for create token, it's because you're not going to use not all functions will be able to essentially receive the ethers. So you want to specify which function specifically can be able to receive money, essentially, to avoid a scenario where if all the methods or rather if all the functions were able to receive money by default, there would be a lot of accidental, let's say, it transfers, right? So that's why if you want to create a function which can receive money, use the payable method. Yeah, and also the fact that it's external, meaning it can be called only outside of the smart contract. By outside the smart contract, I mean, example, in the marketplace, when someone is trying to, like, let's say, buy a token or something, so they're going to when the function is external, they can be able to interact with the function in the smart contract. Yeah.
So the other thing I'm going just to emit an event, like, okay, as Cindy told you, like the other previous lesson, like just like a notification on chain, which you're going to get off chain. So you are supposed to use an address to the sender or the seller. So who is selling this one? So that's the message to sender. Okay, so who is owning this? Okay, currently the owner of this NFT, I've just transferred it, as you can see. So it's this address. So the price and then the token ID. Nice. Guess all is up, all is up, all is good. Okay, so the other thing, like you're supposed now, like okay, now it's okay. So now like the NFT, it's owned by the auction when you mint it. So for example, okay, so like it need to resell it like back to the for example, if anyone can buy it, they can be able to resell it in the auction, like the auction contract. Okay, so like just come here and spin another function. Let's just call it like sell the better name, yeah, that's token. Sell token. So actually it's going to take just like the token ID. Let's go ID. Then actually, okay, for you to resell, actually you're supposed to exactly be like same case to pay for the listing price. So it's going to be like public payable. Okay, then okay, determining anything? I don't think so. Nice. Okay, so literally we have to keep some. You have to keep like some checks literally for us to check is like the one who is selling this token, like is he or she really the owner of that NFT? So I'm going to use here require to check that one. So I'm going to it was ID to market item. What was the mapping exactly? So I'm going to get it. I want to get like the owner of it. So I'm going to pass the ID. Then I want to get the owner. So who is the owner of? So literally the owner is supposed to be the one who's calling this function. Just call it not owner. Okay, so the other check you have to check if the pricing, like they have to pay for the listing price that they are fees for the action. So that's message.value. That's just an inbuilt value, an inbuilt data type. Like it has to be equals to the listing price. Let me just say can't be less greater. Okay, so from there we need now to change some ownership here, literally, because okay, this person is the one who is owning this NFT, so they need to give their like that ownership back to the auction for it to be able to resell it to other buyers. So I'm going to call the market item. Until I'm going to storage because I'm going to rewrite some values. Markets, other things about. So I want to get ID. This market. I want to get that like that specific item, which like lies behind that specific token ID. Exactly. Let me just call it item. Okay, so here I'm going to call item. Okay, item dot. Okay, the owner. Okay, now the new owner will be address this, that the NFT, the auction contract. Oh, it's supposed to be payable. Okay, now I'm going the item dot seller supposed to be payable. Message dot sender. So
okay, and as Ronex continues, because of time, since essentially our 2 hours is up, so Ronex is going to finish the resale it function, and then for the assignment you can finish the last 3. We're going to provide this smart contract and also the previous smart contract which Ebenezer had written in the beginning. So the last 4 functions we're going to like it will be an assignment, so you can finish it, so you can learn more on deep dive into Solidity and also how the smart contract will work. And then afterwards we will hold like another, before we hold the last session next week, we will have another dev hours call. So we're essentially going to go through this and help you in case you stuck while doing the assignment. And also, in case you didn't understand what we had gone through today, because we've gone through a lot of things today. So we're going to hold like a dev hours call next week on Wednesday. So it will be like 1 hour, 30 minutes call. So we'll basically give you a refresher again of what we've gone through this session. And if you're stuck in the assignment, we're also going to help you out. And also we are going to go through some bit of how you set up your environment, because when we start now going to the front end, because after we go through this smart contract and we deploy it, we'll now learn how to make it interact with the front end interface, right? Yeah, so we'll be holding a dev hours workshop next week on Wednesday before our last session on Thursday, so that we help you again if you're stuck with what we've learned today. And also, so you can go back, because we've gone through a lot today, so you can rewatch this video again while tinkering with these smart contracts. You try out the last 4 functions as the assignment, and then you can also try deploying it via Remix, so that you can also learn how to deploy on Remix also. And then next week during on Wednesday, I'll give you guys the specific hour. We'll have like a dev workshop. We'll help you in case you're stuck, you didn't understand the assignment. And also we'll go through this again, and also how to set up the your local development on your machine, so that on Thursday we are well prepared to see how we can create an interface for this smart contract. Yeah, and then finally, after, because it was a 4-week bootcamp, afterwards we'll give you guys like the rest of December, like 2 weeks, so that you can finish up on all the assignments. You can work out the entire marketplace on your own with us as guidelines. And yeah, the best, as I said in the beginning of the bootcamp, we have like prizes. We have mini prizes. So pull up your socks and then you finish up the assignments. Yeah, so we are going to be giving them out to people who essentially present a workable marketplace, essentially. Yeah, so you can finish up Ronex, and then he's going to like write all the guidelines you need for the next assignment and then share it. Yeah.
Okay, good. Okay, should I finish, or maybe we can just leave this function for them?
I think we can leave the functions for them. Yeah, yep. They can be able to spin off.
Yeah, actually, yeah.
Yeah, they can spin off another function.
Yeah, they need to cook.
Yeah, they need to cook also. Yes. Yeah, so guys, thank you so much. We don't want to keep you guys here a lot. Also, today we've learned a lot, so we'll give you guys time to digest everything that we've learned in terms of the NFT smart contract. So we'll share all these smart contracts in our Telegram channel, so that you can go tinker with them. You can rewatch this as many times as possible so you can understand. We can also share extra materials, or if we find them, let's say some extra tutorials on YouTube on how NFT smart contracts work, so that you can get you can reinforce the learning which you've had today. Yeah, in case you haven't understood a lot, it's okay. We weren't expecting you to understand everything today, so this was just like a diving into the deep end of smart contracts. Yeah, so we'll meet you guys next week. Like I said, during the dev hours workshop, we'll all be there. I'll also be there. So in case you are stuck, in case you have any queries, you haven't understood what we've been teaching so far, that will be your chance to speak to us. We'll be holding it as a Google Meet, so that guys can have the chance to speak out. No, it will not be like a streaming like in our normal Thursday sessions. And yeah, next week on Thursday, we're now going to like build an interface for the NFT smart contract, just a simple interface, so that you can have a holistic overview of how everything works in terms of developing on blockchain, especially decentralized applications. Yeah, so with that, thank you guys for joining in today's session. As you saw today, Jordan and I were a bit on the back end, so we gave our fellow members of the team a chance to also become instructors and tutor. I hope you've really enjoyed the session. They've delivered really well today. And yeah, in case you have any questions, always don't forget to. Now, why are you laughing now? Why are you laughing, Jordan? Yeah?
I'm laughing about the Kahoot.
Oh yeah, last week we were actually supposed to be having a Kahoot, and we were having technical. We had technical difficulties, but don't worry. I think since next week it's the last session, we'll hold the Kahoot. Yeah. Also, guys, please don't leave us with our money. We're going to use it for Christmas, so we want to give out the prizes which we have.
I'm gonna
So
choose some
please,
rice. I'm gonna choose rice, guys.
yeah, if you leave us with the money, we're going to use it. Yeah, you're going to chop rice. Yeah, so guys, thank you so much for joining in today. I hope you've learned a lot. Thank you, Ebenezer. Thank you, Ronex. Let me just add Ebenezer to the stage again. Thank you, Ebenezer. Thank you, Ronex, for holding today's session. So we are going to meet next week twice during the dev hours on Wednesday and during our last session on Thursday. And yeah, you have a lovely December, lovely holiday period. Don't forget to code, even if it's December. Blockchain never sleeps, so you also never sleep. Continue building, continue cooking. Yeah, cook.
If you're gonna be cooking, cook pepper soup.
Yeah, cook pepper soup. Yes, so we're gonna be cooking. Let me just see in the comments in case. Yeah, Kahoot. Okay, we are going to hold it next week. I promise. During the last session, and yeah, see you guys next week, same time, same place. As I said in the Telegram channel, we're going to provide more details also for the dev workshop. It's going to be a Google Meet, so you can join in and ask questions interactively. Yeah, and thank you guys for joining in the live stream, even if it's the holiday season. Thank you guys for your determination and your aptitude. See you next week. Bye bye. Love you guys. Yeah. Obviously, it was an awesome session.
Check Decade. We have like 5 courses there. For Celo, there is also an NFT. You can actually use that one to have something to chop for December.
Yes, actually, in Decade, it's a pay as you earn model. I don't know if they still pay when you finish out the courses.
I'm seeing these days they pay in Decade token. They give you 100 Decade token and certificate.
Okay, so it's a pay as you earn. So you have a chance to at least make some money to spend Christmas on.
Can pull up another one. It's called Meta School.
Okay, so all of these resources, Jordan, you're going to share them in the Telegram group as well.
Yeah.
And also Ebenezer, all the links which we've gone through today, you're going to send them in the group as well. And also Ronex, to this week, you're going to be in charge of this week's assignment. So you're going to provide the smart contract which we have not finished. And yeah, you're going to give guidelines on how people will finish the smart contract. And yeah, thank you guys. I'm now going to end the live stream and see you next time, same place. Bye bye.
Adios.